car class last week, and I had written a small test car, which is not yet complete, but it just showed that the object could be created, right? So we'll quickly review our car again, just so that we know what we are talking about, and then complete its tester. And today I'll go on to a little more complicated class definition. So instead of one classes, we'll try to create two classes today, right, in the same project. So we'll do a little more complicated example today. So let me finish this. Hopefully you had everything to finish off your first assignment, right? You had done a tester with me. So it's a simple one. It's not worth a lot because it was an in-class. So it was a small assignment which kind of told me that you know how to define classes and how to write testers. And since I had taught you dialog boxes in my first class, I kind of added it to it, right? But we just had to postpone it just because we were doing more classes. Okay, so let's look at this. So that's due tonight, if I'm not mistaken, right? And please remember the entire Eclipse project zipped to me, right? Don't send me Java files. I'm not going to create projects. It's going to take me very long. So once I have the zipped file, all I have to do is unzip it, and then I can import it straight into Eclipse. I don't have to do any copying and pasting. So it will save time. Yes?
I had a problem in assignment. It told us to ask for salary, but
yes.
It didn't told to ask for monthly salary or annual salary.
But you can always calculate it.
Yeah, but
the field was monthly salary.
Yes.
Right? So you're asking for monthly salary. So when I tell you to show the annual salary, all you have to do is multiply by 12.
No, but I don't know. We have to ask. He will enter the monthly salary, or he will enter the.
No, remember the employee class has two parameters, two instance variables, right? One is the name of the employee, and the second parameter is the monthly salary. So if you're going to set those values, they are of course monthly salary and name, right? Because those are the two parameters you're trying to set with the input of the user.
If it was annual also, I could have just divided.
Divided by 12, yes. Yeah. So it depends upon what you took, right? It depends upon what you do. Usually you will take what the user wants, what the object needs. But again, you could have taken the annual and divided by 12. That's up to you, right? Or vice versa. Because remember, that salary is still returning monthly. So here you have to multiply again. So why do two jobs? Just one job has to be done. The annual salary has to be calculated. But why do the extra? So I'll make it clear, but you can make an educated guess that if you're going to set the values, or your message on the dialog box should be clear enough. If that's clear enough, then I'm okay, right? It should say, please input the monthly, or it should say, please input the annual, whatever it is. And then you divide by 12 and put it, that's up to you. But we'll stick to take the minimum from the user and not do any math with it. Coming back, you can do math with it, okay? So whatever you do, as long as your messages and prompts are clear, I'm okay. And similarly, who brought it to my notice yesterday? I think Navleen came to my office, and before that there was another student. And I didn't realize it till they told me. The assignment says display the information about employee 1 using the toString method, for example, right? It doesn't say anything about whether it has to be displayed on the screen or in a dialog box, right? Whereas in the rubric, it quite clearly says use a dialog box to display the salary. So here are two contradictions, right? So I'll accept both. So whatever you do, I'll accept it because there was a discrepancy, right? I mean, I was just assuming dialog boxes everywhere, but maybe the students read it so carefully that does she want it on a terminal window or does she want it in a dialog box?
Can we use toString for dialog boxes?
Sure. ToString is just returning a string, right? And the second parameter of the dialog box is a string. So it really doesn't matter, right? You can put it in a string variable and use it, but you can directly use it also. Because remember, one of the second parameter, I think the second for writing, yeah, second or third, whatever it is, the parameter is a string. I mean, it is an object and you could put a string in it. So it works. You can call the toString method. It's just a normal method. It's just that because it is overridden and we use it without saying .toString, it's just special in a way. Like constructors are special, right? Yeah, but you could, it's just a message. Okay, so let's quickly refresh it so that we can finish off the testers. So you should by now know how to write testers. So we'll do maybe one more and that's it. I'm trying to see if I can do unit J testing, right? I'm trying to work on it. I'm not an expert on it because unit J testing was not common when we were programmers. You know what we mean? I mean, we used to write testers. It was more human testing. But of course, for the past decade or so, since I've not worked in the industry, unfortunately, in Java, for the past decade or so, unit J testing has become very popular. I mean, those are programs again, but those programs use classes in the Java class library that have been specially created to write tester classes. So since it is a part of your course, I usually do it at the end. Maybe I'll put in a little more effort and try to learn it and start doing it right now. So that way you're getting practice every week, right? So it needn't be a separate topic. Okay. Okay. So remember we talked about car. We came up with some instance variables that say how I look in a car, and we kind of stuck to a few just because there were so many. So we had make, model, the year, and the speed. I had mentioned that I'm going to use a new, the Java time package itself, for your information, is a new package in Java 1.8. And it is interesting. Actually, today I was going through some more things in it while I was writing more examples. I haven't used it, right? It's new, but there is a local time variable. There is a not variable, sorry, local time class. There is a zoned time class. Then you can combine day and month. So you can have an object of type day month where you can save the day and the month, and all checkings are done automatically is what it says. So if you try to give a month value 1 less than 1 and greater than 12, it will throw an exception. Of course, we will catch that exception, right? So I'm finding it's an interesting class. So I'll try to use it in my next example. Okay, I just want to kind of get a little more hang of it, just because it is new. But this is the package that has a few more classes, not only year, but a few more classes. What we used it for, at least in this simple example, was to get the current year. But I did mention that you could declare the year as an year object. You could do it, but you have to be careful. Every time you have to work with it and you want to use it as a string or as an int or whatever, you will have to keep converting it. So it's an year object. I stuck to int just because it was easier. But I did use the class to find out the current year. So we had a constructor that was setting the make and the model and the year to the value provided by the user. Logical, right? You want to go and buy a car. You say, this is the make I want, this is the model, and I'm interested in this year, right? The other one said, if you don't tell me the year, then you're kind of looking for the most recent model. And here it is. So automatically the year was set to the current year. So the now gives you the current year. It is an year object that gets returned. So you'll have to convert it into an int by using get value. Okay, so that was the reason, because my variable was an int variable. If you had declared it as an year, I stuck to int because there was too much of conversions from the year to the int and so on. I didn't need it. I mean, it's not so important to me. I can do my own checking if I want. I mean, it's not a big deal at all. You could, though, if something is available, we should use it, is what I've always said. But if you wanted, you can always say the year should be between, say, I don't know, you could set something 2000 to 2015, right? Because maybe you're just a new dealer. You're only dealing with the past 15 years cars, not with antique cars. So you can always do that check. It's not a big thing. Your set method can always do it. So it is an integer, and it is a value between 2000 and 2015. So it can only be 2000, 2001, 2, so on. And if you don't give an year like that, I set it to the default current year. We can do that. That's not a big issue. That's not tough at all, right? The get make was returning you the make. The set make was changing the make. I was thinking about this yesterday or whatever when I was teaching the other section, and a student asked, actually, he said, once you create an object car in which you say this is the make and this is the model, I mean, you are creating an object, right? If this was for maybe a person who's selling it, a car agency or something, then I would have said, no, maybe the customer changes his mind. Oh, I don't want this make and I don't want this model. But if you are, I mean, it depends upon the application you're creating. But suppose if you were just creating a car object, you still don't have where I'll be using this. And cars can be used anywhere. Cars can be used in manufacturing, right? It could be a Honda application. It could be somebody who's Toyota. It could be somebody who's just an agent. So it depends. If it was just maybe in production where you set, this is the car, this is the model, this is the make, then you will never change the make again. So the set make method kind of becomes useless. So is it useful or not will depend upon your application, right? So you've just defined a car object, but definitely a car object in itself is not of any use till you start using it. Like a student object. The student object is good, perfectly fine, but you'll have to start using the student object maybe in a college environment, right? So as soon as you begin using it, maybe you'll have to change some methods that you may not need. So since this was it's not a useful application, we have not used the car object either in production or selling or anything, we just wrote it. But again, if you say, oh, we don't need it, either you don't write it at all, or if you want to write it, you can make it private. Since we've already written it, I won't remove it. If I remove it, then I'll have to make so many changes everywhere. But if you think that you do not need a set method, don't code it. It's not required, don't code it. If you want to keep it just so that if things change and you want to make it public later, make it private to begin with. Right? So the programmer decides. There are no set rules. Which instance variable needs a get? Which instance variable needs a set? Does it need a get and a set? It's the application requirements that kind of tell you whether they are required or not. It's not a rule at all. No rule. There's no rule at all. So since I've already written it and I don't want to remove it and then change so many other things, I'll just make it private. But you could. I mean, there's nothing wrong in writing a private method in a class. Absolutely nothing. So for me, maybe once it has the model and the make has been set, why would you change it? Definitely in a production house. But then you will say in a production house, you don't produce old cars. Then the first constructor becomes useless. But again, the first constructor is just there. So I was just writing something very straightforward. But depending upon the application, you can change your things. So I'm just making the set make method private just to show you that methods can be private. And I won't be changing the make or the model once I have set it in my constructor. So we'll make this also as a private method. Just because I thought of it, right? But remember, this is not an application at all. It is just a car class, nothing at all. The car only becomes useful when you start using it wherever. I could define a class called $, but then the $, has different uses if in a bank or if paying the fees in the school, wherever, right? So you have to see what is the application I'm writing and do I need the set or maybe even the get methods. You'll say the instance variable is private. I don't want to show it outside the class. Then you don't have a get method. As simple as that. So just to make it a little different from what we've done in the previous example of a simple calculator, I'll just make them private. Okay. And the set year was okay. I mean, you could change your mind on the set year, but again, you could say, oh, it doesn't make sense. What the year has been said, maybe it's in production. The year has been said, you don't change the year of a car. So you could again make it private. So it's up to you. I mean, it's not up to you. It's the requirement of the application. So we'll just go private here just because it's okay. Yes.
We can also use inheritance for us. Like if we have a car superclass.
Yes. So this is your superclass, and then you can create. Absolutely. Yes, exactly.
So you don't need to make private in this.
No, then you just leave it. Yeah. No, you don't. If it is only being used in this class, you will make it private. But if it depends upon where it is being used, then it's public, or we can make it protected. But public, remember, public gets inherited. And then in the inherited class, you can't make it private now. It still is public. That's inheritance. Like student, you could have a class called student, and then we could have full-time student, inheritance, part-time student, inheritance, just because full-time students pay different fees, part-times pay different fees, and then number of courses they can take and so on, right? So you could have a class called student, the super class called student, and then you could create full-time student, part-time student, I don't know, international student, domestic student. There could be so many categories, right? Or you could have student and then domestic and international, and then under domestic, full-time, part-time, and under international, full-time, part-time. So this inheritance can go on to any level. When you start doing inheritance, then you have to be more careful of where should I place things. And that's the main thing, but that's how it is, right? We are trying to reuse data. We have to say we need a bigger definition, like a generic definition, and then we kind of make it more sophisticated. So it's kind of getting broader, though children are, I mean, it is assumed children are below the parent in the sense of hierarchy, but as you go down the hierarchy in Java, the classes are becoming more sophisticated, more bigger in their code, because they're becoming more specific to something. Right? Okay, so I've just made them private just so that you can see a private method because we haven't used it. And two, it makes sense. I mean, if we are assuming if this car was in manufacture, then once make and model has been done, you don't change the year or the year. Yes, if it was only for the application was only for a particular company, yes. So I was thinking more in terms of selling cars is what I was thinking when I was writing car. But of course, if you start writing it for a Honda or Toyota or whatever, then of course they can be constants also, right? They can be. But that's again, or you could have an array list where you're keeping the models maybe, right? So, I mean, again, when I was doing it, I just had buying and selling cars in my mind. So I thought, oh, the customer is putting in this information, and then he or she changes his mind. No, I'm not, or maybe trying to find out about other cars. Maybe we could have a field called get price or something, right? What is the cost? We save the cost also. So the user can change his or her mind. So that was my idea. But a student raised the question, and it's a good question. I mean, can it happen? Yes, it can. You can have private set methods in your class. If you don't want to put them in, perfectly fine. So there was, as I said, there's so many things that are not even included in this car. There is no cost, nothing. We haven't even talked about those things. Just because we didn't, right? The get speed is returning the speed. The set speed we assumed was going to, the accelerate was going up by 10. The deaccelerate was going down by 10. Right? This is what we assumed, right? Again, as I said, you could make this, let's do that at least. Make 10 a constant. At least do something that is, whatever you're using, use it properly. So let's create you could create a class constant if you wanted. I mean, because a constant is a constant, right? So let's create a constant for the speed. So what would we like? And it's private. It's final. And you know what? It is static too. I don't remember. Let's see. We'll know if there's what comes. I don't remember the sequence. It's okay. And what would you like to call it? Names. So we are deaccelerating and accelerating. So speed change something. Oh, we'll follow conventions. Constants in Java are written all in uppercase. I will give it a value 10. Please keep, okay, so it doesn't like it. That means final comes before. That's why there's the red squiggly, I'm assuming. Oh no, okay, now what does it say? Oh, I didn't give its type. Are we going ints? We are going ints. Oh, that was the reason. Okay, so it's not, there's no sequence. I wrote static final first and I'm writing final static now. It's taking both of them. So it's fine. I thought that was what the error was, but the error was I hadn't defined the type. Okay, so constant is a named constant. These are named constants. A named constant, you're giving constant value 10 a name. These name constants have some uses, of course. One, if you know that this value will not change in your code, make it a constant. Giving it a name makes it more useful in your code. So instead of using 10, now I'll say speed change. So what do? That way, I don't have to worry about, like, if I need to change that 10 to anything else, how many places do I change it in? Only one, only here. So if for whatever reason now my accelerate says the new speed is plus 20, that's all I have to do. I have to change the value at 1. So named constants give you two advantages. One, readability. The code is easier and easier to read, right? And two, flexibility. Flexibility in the sense, if you need to make a change, you only do it at one place and you don't keep searching, where is this 10 I've used? I know you can use a control F and make a change, find and replace, but that's not what we are doing programming here, right? So we need to follow good programming principles. So please do this. At least if you're not going to input as a parameter, let's take this as a constant, and wherever you see a 10, replace it. So it was more in the speed, right? So here, and you can actually do this also. Let me do this for you. Why don't we do this also? Just because we are at it. Remember, we have a set speed method. We have a set speed method. Here it is. It is sitting right here. So why don't we use it here also? I'll kind of comment this so that you see it, and then I'll copy it also. So call this set speed method, and to set speed, you want to take the old speed and add speed change to it. So of course, we won't write this now. We'll write this now. Why not? Right? We have a set speed method. Why shouldn't we use it? When we've said we have a method and we'll use it everywhere in the code, we'll do it here too. And similarly here in deaccelerate, if the speed is greater than speed change, we will set the speed. Let me comment this out and just leave it so that you can see it and then kind of go. else set speed to 0. So keep in mind, whenever you're writing class definitions now, we can just kind of do this. No, but remember, changing speed is the job of the set speed method. Right? Changing the speed is the job of set speed method. You're changing the speed. So don't use a method that does the same, just because it does the same job, you're just using it. Use a method that makes sense to use it here. Okay, so the stop speed, oh, you meant we could use the set method here also. No, you said you could use the set stop method. We'll change this also. Here, let's change this also. But remember again, use a method. So you could have called stop here. And you're not wrong. I mean, if the speed is, it's kind of stopping the car. You are stopping the car if you're trying to do more than the speed change. Yeah, I mean, makes sense. No, it's not entirely, the set speed just is more intuitive that you're setting the speed to 0. But
I'm also using like parameters for estimate method and heat.
Yeah, we can do that too. But now I have done the 10 with X. Yeah, you could overload it. The only thing is, I'm not sure with the car, like.
If I want to like increase speed to a particular.
Yeah, but how do you do it? In a car, do you kind of press as hard and then kind of look at the speedometer to see if you've reached that speed? I mean, that's the only thing, you don't input it, right? Nobody inputs it. There's no digital cars yet. So it depends upon, but that's a kind of an approximation. You're kind of saying, okay, I'll push it this much. I'll get maybe 10 more. I'll push this much. So you kind of get into the habit of knowing how much to push or pull away your foot. But yes, you could overload it. Do you want to try? It's not a big deal at all. It will come as a parameter. The speed change will come as a parameter, and you will do the same set speed method again. No big deal at all. Here, just do it if you want to. I mean, there's nothing wrong in it. I don't know whether it's a practical method. I'm not sure about that.
Like if somebody don't want to jump directly 10 units.
Yeah, if less or more, yeah. But again, as I said, because it's manual, the changing of speed is manual. So, I mean, again, you don't know how much to push to get a 10 increase, how much to push, but it's a manual thing, but you could. I mean, there's nothing wrong in it. So this method increases the speed of the car by the given units. That's all I can say, right? And then this will need a param then, right? This will need a param. You will need a param here. Yep, you could overload it, definitely. Oh, add param. You can even call it the same as speed change, just because that's a constant and that's a parameter, it's okay. But if you want to keep it again, you can say something like, what else will work for speed change? Speed, this is not the new speed. Now that's different. If it was the new speed, then we would have said set speed to this new speed. So you can do that also. You'll say, what if I want to input my new speed? Because you're looking at the speedometer, right? You're looking at the speedometer. You could do that also. Even that's fine. So when you push the accelerator, you're kind of looking at the speedometer. That's the new speed I want. You can do that too here. We can do that. Maybe that makes more sense than maybe, but then that is like a set speed, right? If I'm giving the new speed, that's like a set speed thing. But that's a private method now. So here again. So no, set speed is not a private one. It's a public one. That's a public. Of course, we change. So that's the new speed one. Okay, so let's keep to just the increase or decrease. You could be, no, this is accelerate. So this is increase speed. Okay, what else can I say? I don't want to use speed change just because, and we usually go speed increase, like, because increase speed is more like a method name. It sounds more like a method name. So let's say speed increase. I mean, I didn't want to say change here just because it's an increase. Okay, what do you want to do now? Take this and take the old speed, take your parameter and replace it here. So you have a param. And what is the speed increase? Yeah, the increase in speed. That's all I can think of, right? Or we can say to set the increase in speed, right? Or something like that. Increase in speed, right? Yep, that can be done. No big deal at all. You can overload the method. One takes a parameter, the other one doesn't take the parameter. In this one, your speed will always increase by this. In the other one, it won't. You can do the same for deaccelerate if you want. We just have to be careful that we are doing the right one. Okay, so here. So this method decreases the speed of the car by the given, I don't know what to call units. I can't make up. Okay, so here is a param. Let's call it speed decrease. And then to set, kind of not a set, to set the increase in speed, to set the decrease in speed. Kind of a little odd English. It will come out. If I think of a better one, I'll change it, okay? So it takes a parameter. And here we have to check. We have to check that your speed is more than this. If it, and if it is more than this, we have to decrease it by this. There. Yep, that can be done. You can overload your methods. And that's what you do, like. So maybe that would be a better thing to do. So keep both, whatever works for you. And they're both correct, right? They're both correct. There's nothing wrong in it. And I took the increase or the speed you want, though that's not usually what you input. You look at the speedometer to go to a new speed. And that new speed can always be done by a set speed method. But that set speed method is not taking into account going down. It is always taking going. Like it says, is the speed greater than 0? So we won't know. If you're trying to deaccelerate and you're saying my new speed is, and you can't say a new speed less than 0 actually. Yep. You can play around with it. You can improve the class definition to anything you like. You can say new speed. So there is another method called new speed. You check what the new speed is. If it is greater than 0 and it is greater than what it is right now, do you want to, then you just set it to it. Right? Do that. I mean, that can be done too. I just kind of I used the same method. Instead of 10, I went up or went down by a certain value. So the string method, we've already talked about the string method. It is returning you the make, the model, the year, and the speed as in a format, right? It's giving you a format. The stop method is just stopping your car. So I've replaced normal assignment statements with set everywhere now. I've used sets and gets throughout my class. Plus, I've just made a few methods private just for the heck of it, I should basically say, just to let you know that methods can be private. And instance variables can be public for your information. Okay, so now once that's done and it is compiling, now come back to your test car. Okay, so let's write a tester. We'll do the same thing we did in the other. We'll try to create, since we have two constructors, we'll create both constructors. And what methods do we need to check? We need to check the toString. We need to check the gets. The sets now we are kind of saved, right? You don't do anything with saved private methods. You can call them. And deaccelerate and accelerate, and then stop, right? Okay, so let's start. Okay, so as I said, we'll kind of always let the user know what's happening. This is the 2-parameter one. I'm just calling it 2-parameter and 3-parameter because they both have parameters, right? Okay, so what do you expect? If you're going to test the constructor, you are expecting that the make and the model, right? So the make and the model. Make should be Volvo, and model must be S60. Oh, here it is, right here. I should know by now. Here. That's what you're expecting. So write what it is, what are you testing, then what do you think the answer should be, and now show it, right? And let's complete it. Make is this model is this. What about year? The year is current year, and the speed is 0. This is what we're expecting. So the easiest way would be to do this. To call toString method. So you're basically also testing the toString method. So you can make a note too. And you can say again, so we've done we've done two jobs. We've called the constructor and we've also called the toString method. Please keep in mind, you don't have to say my car dot toString. By default, when you write an object name, it automatically calls the toString, even if you haven't written it, because it gets it from the object class. Though remember, we saw that it was an odd number, but you're safe, right? You're safe. Okay, job one done. Let's accelerate the speeds and so on. Accelerate, deaccelerate. Okay, let's do one by one. Let's test the accelerate method. Accelerate. What do you expect? This new speed should be? Uh-oh. Oh. The new speed should be 10. The new speed should be 10. Okay. I'm not sure, did we show something like kilometers per hour or something? I forget in the toString. We can always make it. We can always show it, right? Right, so now call it, accelerate the car. Okay, we have another accelerate also. Okay, we have another accelerate also, right? So the new speed should be 10. So let's now get it. Let's do a printf, just because, and don't forget the percentage n. Percentage integer, right? So d, again, you can show in whatever number of places you want. You can make a whole table if you like. You can make it as neat as you like. I can show you, it's not that tough. New speed is, and again, let's put the percentage n before we, and you can put a kilometer per hour if you want. You can do that in your car also. The car where it returns your speed, here, you can actually format it right here if you want. Because the get speed returns you the speed, you can just create a speed plus, it's just a string, right? You can do it right here. Oh, then we can do that. Then we'll have to return a string. Or we can do it in a toString if you want. Here we can do it because toString is automatically a string. And actually you can format all this. I'm not sure if I have, maybe I'll show it to you in another example, but you can format your answers right in a tabular form. It's not so tough because everything has a format symbol, percentage %s, percentage %d, percentage %f, everything has a size. You can say, I want to show my name or whatever car make in 10, space of 10. I want to show my integer in 2. Or if you don't give it, then it's the default. With numbers, we are okay. Numbers are kind of always printed left justified and strings are printed. They're Java. I could be wrong. I think they're both left justified, right? They're both left justified. We can find out, but you can always make it the opposite by putting a -10s, for example. It can be done. It's not a big deal. Right now, more than pretty, I want to do this. Okay, so percentage, that's the new speed. And again, if you don't want to do it here, you can do it here. But usually this job of returning the kilometers per hour is the job of the car. So it would be better that we do it in the car object. Again, you have to decide what is a better place to do it. And yes, get speed was int, but if you want to add kilometers per hour with it, then we'll have to change the type to string, and our job is done, right? It's fine, but you'll say, what if I want to get the speed here and do some math with it? Then it's better to get it as an integer. Again, these are all small issues that you think about when you really get a real-time application. Then they become very important, right? Roughly speaking, I can just say something.
Also be processed afterwards and numbers can be extracted.
Yes, it's just more work, right? Or we can have two methods. We can have a get speed and we can have get formatted speed. You know what I mean? You can do that too. Like make your life easy and let the car class do whatever its job. So don't try to do it on the application side, on the tester side. Let the car do it. Okay. So we can do that too. You can have another one. Okay. So what's the new speed? Okay, what method? Let's use get speed. and you will say new should be 10, and you can say, oh, and let's also write, I'm not sure what I had, copying and pasting. Let's use the get method. Let's do this. Let's say my car. There it is. Jamie, we are working on the car class that we were doing last week. So what I can do for you is, just because it's better that you come with the class, otherwise you'll be lost. Let me do this for you. Give me 2 minutes, guys. Let me put whatever, and it will benefit everybody, but definitely I'll put whatever we've done till date on Blackboard for you guys. So that way you can pick it up. Otherwise you'll be lost, and then you'll be lost throughout the class. So where are we? Intro here. Okay, let me quickly do it. It will take 2 minutes, but at least he'll be on. Weekly learning is where I'm putting my stuff. Class examples, Thursday. Oh, I had a car project. I'll just replace it, okay? Just because we added a few things to it. So let's overwrite it. That's much easier. I don't have to kind of create new postings or whatever. So this is Thursday today, right? Yeah. And car project. There is car.java. And we are just starting to write the test car. We've written a little, so let me overwrite that file too. Yep, right section. Okay, there you go, Jamie. Okay, so it's on Blackboard for everybody. If you need to pick it up from Blackboard. Okay, weekly learning, Thursday, whatever examples or class examples it said. Okay, so you're expecting that the new speed should be the new speed should be 10, test the get speed method, accelerated, and get the new speed. Okay, so that's the new speed. Let's use the other accelerate method where you give in the new speed, like just because we have it now. Okay, so now let's test. Oh, this is coming from last week. We'll remove it after. I mean, you remove it right now. Okay, so let's do it again. Okay, so now let's test the and what by what? Oh, negative numbers should not work. Did we check that? We didn't check that. See, we didn't check if the input was not a negative number. Yeah, it is in set method, but you should not even take a negative input. But remember, things can happen. Suppose your speed is at 50 and you say accelerate by -10. The set speed method will not catch this error because 50 minus 10 is 40. Right? Or you could have, instead of accelerate and deaccelerate, you could have a change speed method in which you can give either positive or negative values. Like you could do as much as you want, right? So at least in car.java, let's do this at least since we've written it now. I mean, as I said, there's no end to it, right? Where was it? Accelerate. Both of them should be positive, right? Both of them should be positive. Okay, so here. Okay, so if the speed increase, because we haven't designed it well, right? We should have designed it first. It's just how things are coming up. So let's do that. We set the speed. If it is greater, just because we have a parameter now, we didn't have to check this because we were doing it by 10 before. And you'll have to do again here. If the speed increases this, in there you go this and this. I could have formatted, but it makes my comments not so pretty. Oh, this is not the one. Oops. Control Z. The other deaccelerate one is where we needed it. Here. So I'm checking it here. You don't have to put quotes just because this was called field decrease. Just because it's a single if and the if has a single else. But if it makes your life easy, it makes more sense to you, you can put an opening bracket here and a closing bracket at the bottom. The if only has a single statement inside it. The if only has an if inside it. So you don't need the braces. But if it makes you feel better, and that's fine. Just put it like that. Oops, just put it like this. You don't have to, it's not required because there is only a single statement inside if. Remember, this is a single statement. If else is a single statement. They're not two statements. So it depends on you. If you want to do it, if, as I said, it's entirely up to you. Even here you could have, but again, like some people just do it by habit. It's not a bad habit at all. Then they don't have to worry about it if they add more statements, which is perfectly fine. Okay, so we did this because the increase in speed or the decrease in speed has to be a positive number. That's what we've said. Okay, which means we have more work here. Accelerate the car again by, let's go 15. And then we are going to call the other one. So testing the overloaded or the parameterized. That takes a parameter, okay? New speed should be how much? 25. Show it again. Show it again. So the new speed, show again. So say what you're doing, tell what you're expecting, and then show it. Try to now do it with a negative number, right? Try to do it with a negative number. So copy from here. Copy these 4 lines and put it here and put a negative number to it. Instead of minus 15, say minus 15, right? You can do that. The speed should, the new speed should remain. So it will make more sense. Just you're saying it should remain at 25. So remain means it should be where it should be. So you've tested both. 0 will work. 0, there is no problem at all because that's okay.
That won't affect the speed.
Nothing, the speed doesn't change. But it's not wrong, right? Though we've said it should be greater than 0, so for a 0 also we'll get the same problem. We are not allowing an increase of 0. Makes no sense, I know, but it's a valid number. Okay, let's do deaccelerating now. Right, so we've checked our accelerate and accelerate with the parameter. Now let's check the deaccelerate. So deaccelerate the car. How much? Let's just do, oh, we have 2 of them, right? Actually 3 of them. 1 normal, 1 parameter, 1 giving it a negative value. So I've copied the accelerate in 3 places. Let's just say deaccelerate the car. That's the normal one. How much it should go down by? 10. Right? New speed should be going down by 10, 15. New speed should be 15. And show the new speed. Okay. Now deaccelerate the car by 15. Oh, we are at 15. Let's try, just for the heck of it, let's try 12. Just so that when I say deaccelerate with a value that is more than something, we'll have to do it. Okay. Testing the parameterized deaccelerate. The new should be how much? We had 15 minus 12, 3. Right? Okay. Try to deaccelerate. Oh, did I do a mess with something else? Testing the accelerate the car again by 15. Yeah, okay. Copy and paste is never good. I've always said it is never good. I've missed out the minus 15 one, which is okay. Okay. So this was 25 and 15 is okay. After that, you went down by 15. So the new speed should be 25 minus 10, 15. You're now going by 12. It should be 3. Can you deaccelerate the car by a negative amount? No. So by I'm just using the same numbers. Cannot. We'll say something like you cannot do it. So the new speed should remain at 12. Oh, sorry, remain at 3. We were at 3. Okay. We were at 3. So the new speed. Now try to accelerate the car again, deaccelerate the car again by a bigger number. Remember, if it is a 3 and I'm trying to do it by 5, it should stop. The new speed should be 0. So it's fine. You're doing a 5 and I'm just doing I'm just normal one. I'm using the normal one. The new speed should be 0 because you've said, I mean, I've tested it with 10. Either way, both, we can test both of them actually. This should be 0. So I've deaccelerated by 10. I've deaccelerated by 15. I've deaccelerated by minus 15. And then I've deaccelerated it. Its speed was 3. It should just become 0. You can accelerate once more, and the only method missing is we haven't deaccelerated by a amount that was greater. We've done it by 12. We've done it by 12, but like otherwise we haven't. But if you wanted to test, the other one will also work. If the speed is 3 and you try to deaccelerate with, automatically the set method will take care of it. So you can try that too. So accelerate the car again. So remember, we are at 0 now, okay? We are at 0 now. So accelerate it, and now try to deaccelerate it with a bigger value. And try to give a bigger value here. This will also set it to 0. Because this will go up by what? 10, right? I hope I have my percentages n everywhere. That's kind of right. We are accelerating and then we are trying to deaccelerate it more than the speed. Okay, so this is acceleration. So we'll show it again. Where are you? New speed here. That's your new speed. Right, and then you're trying to deaccelerate by you're trying to deaccelerate by 15. Speed should be 0. There, go to 0. There. What doesn't it like? Oh. Yeah, just to show, because I hadn't tested this value of both ways, it is calling the same method, but there it is. So here I was 0, I have come to 0, and then I've started again, accelerating and deaccelerating. So I use the normal accelerate, and then I'm by more than the speed. So new speed is this, and deaccelerate by 15 now. So don't put the dash, it looks like a minus, but that's okay. Speed should go to 0. Job done, right? So we've tested the get speed. There was, we've checked the to string. Oh, the get, make, model, and all that. Okay, not big. Okay, let's create another one. We have to test the other one anyway. R number 2, because we have 2 parameters. So since we have the parameter, the constructor written somewhere, it will just make our life a little easy. Testing the, okay, test the other one now. This is a 3 parameter one. In the 3 parameter one, we have to give an year. Oops, you can try whatever year you want. We'll just go 2012 or 2015, whatever. Right? And we can make a check also in get year, set year actually. Oh, so the make is not Volvo. Let's take something else. A Nissan and a GTR. I had to get the names, guys. I'm not good at these names at all. To go and look them up. And I could be wrong, okay? Okay, so how do we create it? Let's create it. Car object, let's call it your car instead of my car. Let's go new car, and we need to go, that's 1, that's 2, and that's 3. And let's print your car. There. Oh. Or let's test the get methods. Oh. Let's test the get methods. Because that remains, right? We have to do it anyway. This is what we are expecting. So let's do this. Println get make. Again, you can put it in one line. You can do a printf if you want. Or if you just want to kind of go this way and make it easy. Oh, we'll have to give it some heading for sure. Make. As soon as you start giving headings, you just think it is better than just to use it. And again, you can show the new speed with kilometers per hour if you want everywhere. Nobody stops you. Make, let's do a plus. That's it. That's it. How many were there? 4. That's it. Okay, so that's model. Third one was year. You can say year of manufacture. You can make it, the heading can be whatever you like. And the last one was speed. And as I said, with the speed, you can put the kilometers per hour if you want. All you have to, we'll have to use we can put it here, then I'll have to use a printf then. If you want to show kilometers per hour here, just put an F here, right? I think all text and numbers are left here. So I've tested the set methods. What haven't we tested? Oh, stop car, right? Rest all, bless you, rest all tested. Gets tested, set only we haven't set the speed. Okay, we haven't set the speed, though it is being called from all the others, we haven't. Okay, so let's do that. Oh, and positive and negative both, right? So let's do it. Set the speed to 40 and then show it again. Why don't I make it a F? Just because I want to put kilometers per hour with it. Yeah, okay. I just did this. You can actually do this everywhere that you've shown the speed. That's a lot of work, right? It's a lot of work. We've used it at so many places. I leave it to you. Here. And then set the speed to 40 and the new speed should now be, oh, it was 0 here. So it was 0 here, it should be 40. Here. So the new speed should be 40. Okay, now we've done, okay, now let's stop it. I mean, you can do this also. Let's do this. You can't set it to a negative number. We've already tested that, but we haven't kind of tested it with the set speed method. That cannot be done, right? You can change it because it's a negative number. So show it again. Okay, now let's stop the car. There. Stop the car. Speed should be now 0. You can put it in a different line. I mean, I'm just being lazy now. Here. If things work, we've tested everything now. Gets tested, toString tested, set only one tested, accelerate, deaccelerate both tested, and stop tested. All methods have been tested, right? Now try it. Let's see how bad or good it looks. Oh, missing format argument exception at line number 61. Oh, printf doesn't need a plus, it needs a comma. I changed it to printf, but I didn't change the plus. Okay, let's see now. Let's see the answers. Okay, so testing the 2-parameter constructor, make is Volvo, model is S6, year spelling is wrong, is the current year, and oops, speed spelling is wrong, is 0. Okay, calling the toString method. So car is Volvo, say S60, 2016, and 0. Okay, so let's try to do the changes right away so that we know what we are talking about. So there were spelling mistakes right in the beginning. Year is here, and speed is here. Okay, I'm sure we'll get this problem copy and paste somewhere else also. We will. That's okay. Let's come down. So one job done. Testing the accelerate method. New speed should be 10. Test the get. Oh, we've already done the get speed method up. Okay, that's okay. New speed is 10. Accelerate the car by 15. New speed should be. Oh. What didn't we pass? Right. Maybe we just. Oh, I know what we didn't do. I said the parameterized one, but I never passed a parameter. Okay. You see, that's what happens with cheating. Call testing the accelerate, the new speed. Okay, I called it here, and then I never called it. Here, call it. If you don't call it, how will you? Okay, and pass 15 to it. And then we said we will accelerate the car again by minus 15, which cannot happen. So call it again, but with this time with the value of minus 15. So you didn't call it. So if you didn't call it, the speed will remain at 10. Okay, where else now? Deaccelerate the car. Testing the deaccelerate method. New speed should be 15. Okay, so call it. Call deaccelerate method. And just the deaccelerate without the parameters. So you're missing it everywhere. I'm missing it everywhere. Control V. What are we coming down by? 12. Deaccelerate by 12. Deaccelerate. Deaccelerate by 12. So deaccelerate without parameters, deaccelerate with parameters. Deaccelerate with minus 15. Calls are absent everywhere. There, with minus 15. Should remain at 3. Okay, now what? Deaccelerate the car again. Deaccelerate the car again. Control V. Normal deaccelerate. Accelerating and then deaccelerating. Here we accelerated it and then we accelerated it by 15. Oh, this is deaccelerate. Oh, and this is, okay, no, we are at the same car. No, have we started the new car? No, we haven't. We are okay. Deaccelerate. Sorry, guys. There it is. It's logical, but just do it, okay? Find out the places. Accelerating and then deaccelerating. Accelerate it and then deaccelerate it. And should go to 0. Yep, should go to 0. Show the new car, new speed. Testing here. Here is the new testing. Okay, new testing. So spelling mistakes again, maybe. Yep, spelling mistakes again. We didn't do any acceleration and deacceleration here, so thankfully we'll be okay. Okay, let's try it again now. So the answers are wrong means something was missing. Okay, so we were okay till here. New speed should be 10, the new speed is 10. By 15, new speed should be 25, is 25. Deaccelerate by minus 15, nothing should happen, nothing has happened. Deaccelerate the car again, the new speed should be 15, it is 50. If you like, you can kind of put this in, I don't know, maybe put stars below and after, before and after, so that you know you're printing out something, because these kind of come together, but that's okay. We are just testing for now. Deaccelerate the car by 12. The new speed should be 3. It is 3. Try to deaccelerate by 15. Nothing should happen. Nothing is happening. Deaccelerate the car again. Should go to 0. Is going to 0. Accelerating first and deaccelerating by 15 should be 0. Is 0. Okay, so all methods are correct in the first one. Right? They're all correct. Now the get methods. Nissan GTR 2020 0 kilometers per hour. Pyramid constructor is working. Next, set the speed to 40. Set the speed to 40. Oh, you know what is happening? Copy and paste. It's not my car now, it's your, oh no, it is your car. Oh, again the same thing. Set the speed to 40. Who's going to set it? Accelerate. Right? Oh, this is set speed. Okay, so your car, what was the method? Set speed to 40. Okay, if it's not there, it won't work. Okay, let's take that. Control C. Set the speed to minus 20. Cannot happen. Set it again to minus 20. And then stop the car. Speed should be 0. Stop the car. Speed should be 0. There. Okay. Run it again, and only the last 3 statements are what we need to check. Just the last three now. Okay, so set the speed to 40, new speed is 40, set the speed to -20, it should remain at 40, stop the car, it should be 0. All done, right? It is all completely done. Everything has been tested. But that's what testing is. Testing is as tedious as writing. Tester is a profession, right? You could be a tester instead of a programmer. You need the same kind of knowledge. You still need the same kind of knowledge, and you'll get bored very soon because it's a tedious process. But definitely that's what JUnit kind of makes it different. But again, the things still remain the same. You're using the same assert classes over and over again, right? So if you don't have it, you can pick it up from. So we've done it. I'm going to put it back, okay? So the newest now is on Blackboard. Both the newest files are on Blackboard. And again, as I said, we could have added one method called change speed and not write accelerate and deaccelerate separately. We wrote it separately because we were talking about overloading methods and we overloaded this. You could write a change speed, give it a value. It could be a negative or a positive value. As long as that negative, all you had to do was add it to the speed. So change speed, if you put a positive value, it will go up. If you put a negative value, it will come down. But you always have to check that you cannot go below 0. We don't have a maximum speed, but you cannot go above the maximum speed. You don't have a maximum speed. Every car does have a maximum speed, right? It's defined. You can't go beyond it. Every car is made that way, as far as I know, because we were talking about cars in Germany, I think, which can go till 200 or something per hour or something. So I'm
200 here.
there are certain roads here too where you can. But is a car, I'm sure a car's engine determines how the maximum it can go to. I'm not talking about the maximum speed limit. I'm talking about, can it go to, every car engine must say this is the maximum speed. Otherwise, I don't know, maybe the car bursts. I don't know. What do you think? It is? It should be.
Similar, like most cars in Canada can go 200 to 220.
220,
That's
okay.
the maximum the engine will allow.
Allow.
Maximum energy.
Exactly.
In Germany, kind of the same thing.
Yeah.
They can just.
There the speed limit is more. There the speed limit is more, I think. That is the only thing. And I think you're right. Somewhere in Canada also there is a place where where the speed limit is more for, I think, those racing cars or something.
407, they're testing a higher speed limit now.
Oh, okay.
The Autobahn in Germany has no speed limit.
Oh.
It uses common sense. So if you feel you can go 150 kilometers an hour, go
Go.
150. If you feel you can do 200, go for it. Italy, they're a lot lower.
The lower. And in India, you can't do anything. There's so much of traffic. You have to, you just have to do what you have to do. See how easy it is in India, right?
Getting more than 30.
Yeah, it could be. Like, it's so bad. Just because people are influxing India, Delhi actually, I only know of Delhi. People are influxing Delhi from all the parts of India, right? And like, I can't handle it. You can't cross the road. The cars just don't stop. Like, it's so tough. Life is so tough. And it wasn't so, say 15 years back when I came, it was completely fine. Like, it was fine. You could, I mean, there were cars, but it was okay.
I saw one friend in Vietnam. It's kind of the same deal, but not as many people, of course.
Yeah.
But instead of just waiting to cross the road, he just went.
That's what you do in India.
The cars just go around you.
You just, that's what happens. Like, I don't know how people handle it, but it's really bad. But
Nerves of steel, I guess.
yeah. And there you don't need a speed because you can't speed at all. You can't speed at all. Okay, but yeah, I mean, I know that has to be a limit and I appreciate it. I mean, that's what it is, but common sense should be allowed because sometimes when you're returning home late or going by back road or something and there's nobody in sight, like no other vehicle, you should be allowed to go maybe 40 more or maybe 20 more, some leeway that you should be.
That's what they're playing with on highway.
Highway 407. Yeah, I think it's common sense. Though, of course, there should be an upper limit for sure, like upper, maximum. But I mean, anywhere from say 100 to 150 should be allowed, depending upon common sense, of course.
That's generally what people do.
Yep.
Anyway.
Yeah, like, I don't know. My son came from Ottawa on the long weekend and it was really heavy. This normal 400 and everything. He took some back road. I don't know where he came from. Another route, he said. He said it was empty. You could even, though it was 80 was allowed just because the roads were all winding or whatever. But like you could go 140 even because there was nobody there. But anyway, I'm sure he did. But like, yeah, that's what you guys do, right? Okay, so taken care, we've taken care. Again, I'm not saying this is the best of the classes. We have missed many things. We could have improved some methods, I'm sure. But like, as I said, in an educational environment, you have to kind of create more and more examples just to give you more and more practice. In the real world, you work on a project and you really work on that project, right? So therefore you make it foolproof. And here we cannot make it foolproof just because we are restricted with time. So the idea should get into your head, the concept should get into your head, you should understand why and what you are doing. And I'm sure then you can convert it into the right idea when the time comes. It's like having a good foundation, a good base. Concepts should be clear, is what I think, right? So we'll stop here. But again, as I said, we just thought about, oh, we could have added a change speed method and gone positive or negative. We could have added a max speed instance variables and not go beyond it when we are accelerating. And we could have, right? And we never design our programs, our class definitions like we do here. I try to take your input and then I choose a few and then I go ahead with it. But again, you get the idea, right? And as you get ideas and as you have ideas, throw them at us so that we can all say, oh yeah, that makes sense or that doesn't make sense. You know what I mean? And that's how you will start thinking. Could I have done this? Could I have done this? Okay, so this is done and finished. I don't think there was anything that you needed from here in your assignment 1, but I still gave an extra, like I gave Thursday just so that if there was anything and you needed to come and talk to me, I gave 4 days, I think, to everybody after I posted it, irrespective of the section you were in. You had already done what was needed for the assignment last week. I just waited for the other section to do it. So now that we have more, in the sense you have more experience now of creating classes, I'm hoping that you've gone a little better. So some students came from a background that they already knew classes, but there were some students who were still struggling with what a class is and how to create classes. I hope I have brought all of you on a common platform now. At least all of you should know what a class is and how do you define a class and then how do you use it. And we'll keep practicing, except that now we'll have to go a little more complex. I mean, we can't stick to one class. We'll have to start playing with classes because we know that objects are used from one class to another. You use objects of the Java class library all the time, right? So we learn how to create more than one classes. Are we okay? Anybody who thinks that they're still a little behind? And you know what? I can privately do things for you. Come and see me. So there are 2 choices and you should pick up both choices. You should ask for extra help from peer tutoring. Talk to Ross, email him and say if you can get a peer tutor. It could be a person from your class or it could be a senior person. We have semester 4. And 2, you can always come to me. Just email me and say, when can I come? And we can do that because you need practice. So just listening will not help. You will have to practice it yourself. And I say go to a peer tutor more than I say come to me because you've already heard me. You know what I mean? And then if I say the same thing again, maybe it doesn't go into your head because I'm saying the same thing. I'm not saying it in 10 different ways, kind of. So sometimes students get it better than from another person if they listen to another person. So right now, nobody else is teaching Java. Fortunately or unfortunately for you guys, I'm the only one teaching to both sections. So the other option is ask for peer tutoring. And you know what? We are in week 4. I wouldn't wait now. Get it. Okay? And come for help. Like I was here 12 and class was at 12. So you need some time. You have to put in time and effort. And I'll help you. I mean, I'm ready to help you. No big deal at all. I can repeat things 100 times. My aim is that it gets into your head. And we can do that. Okay, you can close these classes if you want now. Where are we? 3:13. Oh, maybe the right time to take a break. We'll take a break and then come back 20 minutes, please. And then come back and we'll try to do something again that may seem like obvious to you in the sense you can make a connection. So we'll try to create a student class. And again, everybody knows what a student looks like and what he or she can do. And then we'll try to use that student class in a lab class, like in a classroom. So how do you use students and how do you create lab classes or normal classes like a class? So this is again, that should make sense to you because you are students and you attend classes. So we'll try to do that now. Okay, so my aim is to bring examples that you can relate to. Calculators, cars, students, classrooms, things like that. I don't know. I'm trying my best and you can give me your feedback, whatever it is, whatever you would like to be improved, we can do that. Okay, so let's take a break. 20 minutes.